Welcome to today's webinar. Again, today we're going to be focusing on defeaturing and how that can improve analysis runtimes. My name is Roman Walsh. I'm Application Engineering Manager here at SpaceClaim, and I like to get right into the software and show you a few things. Just a little housekeeping before we begin. For those of you that are unfamiliar with GoToWebinar, who maybe haven't come to our webinars before, there's going to be a GoToWebinar user interface on the right side of your screen. If you have any questions, please don't hesitate to ask. Type in any questions you have. I'll get to them maybe during the session if I can, or I'll try to get to them at the end of today's session, and if not, I'll be following up with anyone who's asked a question to me. And also, at the end of today's recording, we will be emailing this out to everyone who's attended. So if you missed something, if you need to get a sandwich, don't worry about it. We'll send you a recording later on. So just a little bit about SpaceClaim before we get into the software. For those of you unfamiliar with SpaceClaim, what we do is we focus on a few things around analysis, and that's bringing in other models from STEP, IGES, Parasolid, native CAD systems that are out there like CATIA, ProWe, Inventor, and allow you to take those files, work with them. That can mean defeaturing them to simplify them for analysis. That could be removing components in an assembly, any number of things that you might need to do to get it ready. Because that's what we try to do. You can think of it like CAD for CAE, where we'll take those models, prep them, get them ready, before you actually take them into an analysis package to mesh and to solve. So the key things that we'll do is repair models, defeature them, and again, get them ready. And so what do I look for and what do I think about when I think of simplifying your models? Now, the problem with just saying simplify and just saying defeature is that it can mean so many different things to so many people. And that's why I like a tool like SpaceClaim, because what it does is it empowers you as the analyst to make the changes you need for your mesh. If you want to remove rounds, remove the rounds. If you just want to get rid of holes or just want to get rid of some small faces and merge them together, just do that. A lot of times you've run enough of these to know what to look for. I'll point out a few things that I've heard that people look for, and also I typically look for in models, such as really tiny faces that can bog down a mesh, also thin faces that may be there, larger, thinner faces, which may cause issues. And also, of course, if you're doing an assembly level analysis, most of the time, again, there are exceptions, but most of the time you don't need to have every little last bolt in the model for your analysis of your mesh. I mean, that can just add hundreds of thousands of nodes and elements that can really bog the whole thing down. And what this defeaturing will do, what this simplification will do, is it will make it a lot easier for you to do more runtimes, figure out more solutions, tweak models, make suggestions back to the design team, and really converge on the best design or a better design much faster. So again, I usually try to keep these introductions really fast so we can get into the software. I don't think I set any records today, but I was off to a good start. And so with that, let's get into the demonstration. I'll show you how SpaceClaim is really CAD for CAE. I think that is the best way to look at it. And so I have a few models already opened up. I mean, this one I initially brought in from STEP. And again, before I go on with the demonstration, I do want to encourage you where if you do have any questions for me of the software, the company itself, definitely don't forget to type them into that chat box. Now, a few things that I like to cover and like to go over, and some things I'm going to show you today to help defeature and simplify your model. A lot of it is going to be filling and removing things that aren't necessary, and the second thing is going to be searching for these things to remove and defeature and simplify, because that's the key thing. If we have things that really are unnecessary for our analysis, things that aren't needed, razor embedded text is it's just an easy culprit. Doesn't add anything to the structural integrity of the model, or doesn't obstruct flow paths that much. So this is something you can really nicely fill in and get rid of on the part of design. So that gives you a nice clean surface to work with. And then as far as going through and filling things in and simplifying them, fill is always just about removing what you don't want. And again, what you want and what you don't want, that kind of depends on you. I'm going to be showing a lot of different things of how we fill in and defeature things in the model. But the key thing to remember with this is how quickly and easily you can do it. Because a lot of times 5 minutes of defeaturing can save you half an hour of runtime, depending on how many times you're going to be running your analysis, especially when it's this quick to select on rounds and find them and remove them. And speaking of finding them, this is that selection panel I was talking about. Because you'll notice what we do and what we work with in SpaceClaim are dumb solids. So a step file, an IGES file, there's no kind of quote-unquote features in the model. It's just geometry. Luckily, that's all we work with. Our focus is geometry, geometry, geometry. So when I select on a round and I search for things that are equal or smaller, it finds those for us. And I can use, again, that handy tool, fill. That's what I use to get rid of them. And actually, the shortcut for these tools, I mean, we tried to make the shortcuts intuitive and simple, so F is the shortcut for fill. So if you see me fill some things in and don't see me click the button, that's what I'm doing behind the scenes. Now you'll notice it didn't remove some of these rounds over here. I'll get to those in a little bit. But what I want to do is also point out that, again, for things to remove, it's up to you. These might be small, thin faces that, again, aren't adding much to your analysis. That's the type of thing that I like to search for, find, and destroy with fill. And the whole thing with searching to remove these types of things and types of features is it's fast to fill, fast to select, but you can make your life a lot easier by even speeding that up, kind of putting that turbocharger to it, by actually searching for things of the same area, things of the same size. So instead of removing one depression at a time, you can find all of these similar depressions on the model and get rid of them together. So the whole key thing is that SpaceClaim is fast at removing things, but even that, it can be faster. You can do a lot to even boost your productivity with SpaceClaim. But the key thing with this is that what I mentioned earlier, what it does is it really empowers the analyst. Take something, I mean, this is a really simple example, but take something as simple as this little outlet. You have the power to fill it and defeature it the way you want to. I mean, possibly if we're doing a structural analysis and we're not concerned about the torque on that hole or the stress that's going to be there, you could fill in the whole thing. Select the whole thing and get rid of it. However, if you're doing fluids analysis, I mean, you might really want to just actually take the teeth off. Take a hole like that and pull a face up or pull a face down to slice it away. And you're left with just that hole. Or maybe it's really crucial that you maintain the edge of the teeth geometry that's there. To us, it's all about giving you easy ways to, first of all, remove geometry, but also create geometry. I mean, if I want to pull that to create a surface to cut with, I can revolve that edge around the axis, giving me a surface that's there. And for me, if I want to take and just cut with that, pull adds geometry, pull cuts geometry away. Or I could have used our split solid tool to slice it away. Or I could have sketched my own circle that's there. The key thing is these are so many ways to skin the cat and so many ways to get the geometry the way you want for analysis without relying on the CAD team. Because sometimes that kind of delay and kind of querying going back and forth can take a long time. And this small example here, there's some strange rounds, like a variable radius here. That could be affecting our ability to remove some of these rounds. That's why we built a round tool that specifically was built to get rid of these things. And first of all, it only lets you select on things that are rounds. Secondly, it might be hard to see on this model, but there's two pink lines hovering over the edge. Notice this is the length of the edge that I have. What this does is actually slices and subdivides these rounds for you. making it easy to remove and fill just one area, one section of a round at a time. So you can start to get rid of what you don't want on the part of the model or the design. You can slice up areas or parts of the model, and you can start to quickly fill them in and get rid of them. And again, I'm just hitting F for fill to get rid of it. So even on more complicated sections, we have ways to tweak and remove it. And notice this can be problematic as well. I mean, that could be, this little edge could be worse than the actual rounds that I might have been removing to eliminate. This is the thing. I mean, you could sketch a new line to connect them. You can just move geometry on the part in the model. So if I want to move this edge to change its position, sure. Move it to a new location, or move it up to the point. Covering that up. Making sure we have 4 edges coming together at this one point in section. So again, a lot of different ways we can clean up these models for meshing. Now, another thing that I want to look at, I'm going to open up another model. And again, you can open up geometry from, like I said, anywhere. Generic file formats, STEP, IGES, Parasolid, ACES, proprietary formats like CATIA, ProE, NX, SolidWorks. You can open all of them up and prepare them inside of SpaceClaim. So I'm going to open up a quick ACES file here. So when I have this open, and it looks pretty clean, looks like I'm ready to kind of, I could remove some of these rounds maybe I want to get rid of a few things in the model. But what's kind of nice about this is I can go through, and one thing that's important to search for, like I said, is small faces and thin faces. What this lets me do with our small face search is it helps me to find things I might want to get rid of. Because again, I can search for criteria, I can search for rounds, or search by an area, or a sliver distance. So if I increase the sliver size of this model, notice I found some faces here, and I found some faces inside here. Let's take a look at these faces first. So mark these as red, and this is actually a key thing. And this is an important point that I guess if you've done enough analysis, you've probably seen. This is an undoctored model that I got in. But this is the thing, is that a lot of times there's sometimes things in the model which either it was designed on accident, there was no intention for that to be there, they probably meant for this face to be this face. This is the key thing that I like to show and talk about, is that what SpaceClaim lets you do is it lets you prep the model for this. If you get almost a mistake that's there, don't worry about it. SpaceClaim lets you, again, clip rounds, like I was showing you before, to remove a section of a round or a model. Notice how you can just start to clip these to remove sections you don't want. And you can actually box select to grab just rounds you might want to remove and eliminate. Give yourself nice, clean faces to work with on the part and the model without having to worry about how the part was originally created. So just grab the rounds that you want to get rid of, fill eliminates them. Now that you have some of these rounds eliminated, let's just get rid of this. You can pull a face out. I can snap it up to our face here, giving us that nice, clean face we wanted. And if I want to put some of the rounds back, because maybe you do want the rounds in the model. With pull, you can add rounds. Pull can snap one round up to an adjacent round on the part. So notice pulling a round chain up to an existing round can put some of these rounds back for us. Again, without having to know or care about how the part was originally created or made. Simply pulling our rounds back into the model. But now we've eliminated that small sliver face, which really could be a pain when meshing. But that's the key thing that this lets you do, is it lets you work with incoming geometry, again, any way you want. Let's look at a few other things with small faces. So I found, again, some sliver faces in the model here that I want to take care of. You can also search for just size of a face. So let's say I type in 10 millimeters. Not that I will remove them or have to remove them, but it helps you just start to see where potential problems might be located. These rounds look fine. I'm going to leave them on the part in the model. But notice some of these parts here. These small chamfers, I can probably just get rid of. I don't need them on the model. I can click them to remove them. Or, let's go back to selection. This is the key thing. If I want to speed this up, I can select on one chamfer, hey, go find me all the other chamfers on the part of the model. And with one F, with one fill, I can remove them at the same time. So again, fast ways to find and eliminate potential problem areas. This is a great example here. It looks like it's falsely identifying something here. Looks like there's a red area here. If I do a big box select, look in the bottom right-hand corner of my screen. How many faces do I have? It says I have 4 faces, even though it looks like I only have 3. That's because there's a really tiny sliver face that's there. If I go into a cross-section and I zoom in, this is that face that was there. It's such a small face on the model, on the design, this can definitely cause an issue in meshing. This is why I like to be able to select these faces. You can see it in the cross-section. Fill eliminates it. Fill brings it to that sharp. Gets rid of these potential problem areas. And in fact, if we want to go through and eliminate all of these, same thing. Same tool lets me select and fill to eliminate them. Another thing we'll get rid of and start to look at is, let's say I go back to that small face tool, starting to search for them. I mean, most of these look like they're on the outside of the part or the model, but this example here, you'll notice, you can see there's something kind of inside that part there. This is something that's really cool about SpaceClaim. There's not a lot of good ways to see inside of a part when you have all these other faces kind of blocking the way. What SpaceClaim allows you to do is, even on complicated models with openings that you can't get into, you can clip that model that's there. I can just create a clipping volume or a clipping area, and notice everything outside of that is clipped away. So you can see inside of the part of the model with what's going on. It looks like someone made a sketch or a circle. This might have been one of the holes on the upper side of the part that they forgot, and now it's cut away. This is a small sliver face that comes together, and that's something I might just want to fill in. Bring it back to the rounds that are there. I won't have to worry about that when meshing. And in fact, if I wanted to go and actually take a look at this somewhere else, that volume that I just made, I can move that volume around the part in the model to the other side. This is what's really neat about this clipping volume, is that you can move it around the part, move it along the model to different spots in different locations. And in fact, if I start to bring this to the other side that's there, remember that small face that I originally saw inside the part? Take a look at some of these faces. This round here, actually, let me make this a little bit bigger so we can see it better. This round here, I'm going to clip with the volume and resize this and make it a little bit bigger. Let me just move it to the right a little bit. Look at this round. This round is actually coming from the top. It's sliced here. It's going down, and it's turning into this round near the bottom of the part. This can definitely cause a problem because there's 2 really small faces that are going into a third face. This is something that I definitely want to take care of and eliminate in the model. This is a perfect example of that round tool. Specifically designed to slice rounds up and subdivide them and get rid of anything you don't want on the model, you don't want on the design. So now that I've eliminated this, no problem. a big box select will grab me all those faces, grab me those two thin sliver faces that are there, and with one fill, F, get rid of them. And now I can decide how this should look. Do I want this round back? Do I want to fill that in? Do I want to just pull this edge up to here? Or maybe I put a round back on around this edge, pull it up to here. Again, letting me put back, actually, maybe it's because of this, we had a bigger round here on the side. It's up to me. I can have it vary, I can fill in the bottom half that's there. What it does is it lets you have a lot of control over how you're simplifying and how you're getting geometry ready. So let me go ahead and turn this clip off. Let's look at one other model. So it's shown some cleaning up parts, getting rid of small faces, eliminating slurs that are there. Let's take a look at an assembly though. I'm going to open up this assembly model. So this is a housing for a computer. Notice there's a lot of details, a lot of holes in this model, which can sometimes be represented with just in a fluid analysis, maybe how much material is going to pass through. So we might want to get rid of some of these details, some of these from the model. Also, there's a lot of, I'm imagining, small parts in the design as well. Because if I do a box select and just grab everything on the model or the design that's there, it'll give us a quick count of how many parts there are. So there's about 750 bodies if I look in the bottom right-hand corner of my screen. And again, just to remind you, or if you do have any questions, please don't hesitate to ask. So let's take a look at how we could or might want to simplify some of these in the design. Let's take a look at the back plate. I'm going to go ahead and open that component on its own window. And I'm going to color it red so we can see it better. But now that I have this, notice some of all these holes that are there. We might want to eliminate them. So again, a nice box select will grab the geometry that's there, and that's 900 faces. 900 small, tiny faces that by filling in, I can get rid of. Or even all of these faces here. If I want to grab them and eliminate them, that's 1,300 faces. Fill gets rid of them, removes them from the model. And now I might want to, again, I might not want this to be a solid plate though, for weight purposes and for kind of maybe how structurally sound it is, or maybe just for allowing for doing a thermal analysis or fluid analysis, I might want to create just a region for things to pass through, or just to remove some material. Sketch anything you need, pull anything you need. That's the whole part of it, is that you have easy tools to create geometry when you need to create geometry, but also edit incoming geometry how you want. And now if I go back, you can see now we have this defeature and simplified section, which is going to be a lot easier to mesh, just with those two quick changes. Let's take a look at this front part that's maybe a little bit more complicated. First of all, I mean, this is what I was talking about. I mean, this is just too much detail. If designers are giving you models with this much detail, there's an issue. You don't need to have the words USB written on your part. So what I'm going to do is I'll just grab them and, again, fill lets us remove them and get rid of them on a part or the model that's there. Same with holes that are there. But what I'm going to show you is maybe a really quick or shortcut that's actually really interesting and really fast. So there's a lot of faces that are there for all these holes in the model. It's going to take a long time to simplify and fill them in, just because there's so many faces that I can tell on this part. One thing that's neat is I can actually take, if this is a thin part, this is a thin sheet that's there, I can just take all those inside faces, copy them, and paste them. Now you'll notice what I have is, instead of a thick solid, I have a thin surface body. And that's sometimes people will do just to get a thin body for analysis. But what I have now is just, it's going to be faster to simplify and remove things on this. Because that handy search tool that I've been talking about this whole time we'll just grab surface holes. So these are any holes that are on there that are smaller than this initial circle I selected. And if you look in the bottom right-hand corner of my screen, that's 6,700 edges that I'm getting rid of on this design. Which, that's a lot of complexity, which probably, I mean, some analyses, again, up to you. You may want to keep it and just want to have your mesh chug and chug and chug. Other times, to do a faster analysis, get rid of that. Now that we have the thin surface all cleaned up, all 6,000 edges were removed, we can thicken this. Thicken this to whatever distance or whatever thickness that initially was. And now we have, I'm going to color this red so we can see the difference. We have our red model, all the holes, all the features removed. And we have that blue one with all those details still there. And so in our overall analysis, if I want to delete that, I'll delete it. Give myself a simpler design, a simpler thing to analyze and worry about. But the last thing I might want to do in a design like this is start to get rid of small parts. Because again, there's about 750 parts in this model. What I'll typically do is I'll select something where I probably don't want anything this size or smaller. Just ballparking it for now. That handy selection tool, which speeds up the elimination of things, also works for bodies. And the common thing that I search for is, I usually search for area. So you can search for a given area. I can say, hey, actually everything that's below 500 cubic millimeters or inches, depending on how you want to work or operate. But now what it's done is, notice it's found 432 bodies. If I hide everything, you'll see it better. But these are all things that I probably don't need in my analysis. Kind of looks like a skeleton now. And actually, these screws, they have their threads on them. Probably too detailed for my analysis. And these PEMs I definitely don't need either. But now that I have them, I can delete them. One click of delete will remove them on my model. But what I also might want to do is just save them. Put them on a new layer. Kind of organize that model for analysis. And just call this small, useless things. I mean, maybe I want to take one or two things back and add it back into my analysis, but for the most part, I probably don't need these. So why not put them on a layer, hide them, tuck them away, and if I ever need them, I can go back to them. Or if I want to search for other things that I might not need on my design. Search, use our selection panel, find them, use this to organize the design, organize the model. Maybe I want to search again, type in the size that I want to search for on my model. Notice I have, let's say, I have about 182 bodies still left. See what I grabbed, see what's going on. And yeah, I might want some of these. I might not want some of these. I mean, things that are purely cosmetic, I can probably select and eliminate. Just go ahead and delete these bodies. But everything else, yeah, sure, I'll put them on a layer. Put them on a layer and store them there. Put them on a layer called maybe useful, may need. But that's what it lets you do. It lets you prep models, prep assemblies, get things ready for analysis the way you want to. So with that, pretty much wrapped up the demonstration, kind of what I wanted to show you today. Hope you've seen a few different things about how SpaceClaim will take and start to clean up and simplify parts, simplify assemblies that are there, by starting to remove features that might not be needed or might not be necessary. So again, with that, I guess I'll go ahead and turn this over to questions. Let's take a look at the list. And again, if you do have any questions, feel free to type them in. So one question here is, how did you do that clipping? So that clipping that I was doing, again, that's useful to see, again, inside of parts. And really any design that you might want to work on and show like that, simply right-click and you can clip with a volume. And you can either select a few things to set it, or by clicking set, you're basically drawing a sphere. The first click starts it, the second click ends it. And that's going to be the size of that sphere you're making, and that's what's going to clip with. And again, if you right click, you can then change the size of it, or you can move it to a new location. Or you could clear your selection and get back to the 3D model. So one question is, how do you create new faces in SpaceClaim? So to create new faces, I mean, you could mean a few things. I mean, first of all, just any of the sketch tools that are there let you sketch new geometry. So if I sketch a rectangle on the part or the model, that's basically going to imprint that on the face. And then pull will let me take that face that I just imprinted, and I can create geometry from that. I can pull it up and it will make a boss or a protrusion. I can pull it down and make a cut. But that will create new geometry that's there. Let me just go ahead and make this full screen again. Actually, I'm going to put up a new SpaceClaim to make this full screen. But the other thing that you can do to create new faces, let's open up a quick example again. But another way to create faces or split them, I would use our split face tool. I use this sometimes just to partition areas for if I want to apply a force in just a small location. What it will do is let you select a face and lets you split it into different faces, different regions. And this can be used to split multiple faces up just by control selecting them. So I can split a bunch of faces at the same time. And that's just helpful if I want to, again, apply a force to the bottom faces or use them as a boundary condition. Another question. How long did it take you to become an expert in SpaceClaim? Well, just a little bit of background about me, just for people that are interested. I'm usually not that interesting, though. But what it lets you do, I've been working with SpaceClaim for 6 years now. I started right out of university, came here and worked in the application engineering department, worked in support for a little while. But it doesn't take 6 years to become an expert in SpaceClaim. I've been giving these demonstrations and webinars since about 2-3 weeks after I started. So it definitely doesn't take that long to be an expert. It's good to know a few tips and tricks about what's going on. And if you ever have questions, that just reminds me, don't hesitate to contact us. We like to help people out. We want people to get good with the tool and get up to speed. So if you do have any questions, definitely don't hesitate to reach out to our support team. How does the Find and Select tool, quote-unquote, know what you're looking for? Faces, small holes, or other things? That's a really good question. So what we do is we've tried to use this selection panel, and what you select on is basically what it searches for. So notice selecting on this face here, it found me an equal radius cylinder, which is this one. It found me face of the same area. It's that same face over there. It found me a depression. It thinks both of these two faces together are a depression. These faces here, those three faces, are coaxial faces. So it selected all three of those faces. So what it does is it just takes what you select on, an edge for instance, edges the same length in the same face, edges the same length on the part. I notice in this case, purely by coincidence, these edges here happen to be within these edges over here. So it's selecting them for me as well. But so it's basically just using what you select on as that search. So rounds have a special search setting, as do holes. Last question. I think we have time for one more. How do you create an assembly of parts? So if you have a part or a model, I mean, you can create an assembly a bunch of different ways. I mean, for instance, this is a single solid. If I cut this into two solids, cut it on this top face, I have two solids. by moving them into new components. I have a component called top. I have a component called bottom. And because I am not good, I put them in the wrong buckets, which is okay because you can drag and drop them from one component into another component. But now what you'll notice is that these are two different bodies that are there that I'm working with. And I can actually use our assembly tools to assemble them. I can align one face to another face to line them up. So I can start to snap faces to each other and to get this into position. So these are using assembly commands to start assembling these parts together to one part. I could have also created an assembly, though, by inserting a file. If I insert a second file that's there, like let's say I inserted that ACES file into this design, I can bring that housing into this nose cone assembly. So now I have this part that I just brought in also in my design that I'm working on and using. So again, there's a lot of ways that you can start to bring in different parts and models and assemblies into one design to start to create an assembly. So now we have three parts. We have our housing, we have the top and the bottom of this. So with that, I'm going to go ahead and close out today's webinar. So again, have a great day, everyone.